This is a technical demonstration on how the business partner agent supports locales, allowing different installations to use different wording most relevant to their users. In this example, we have the Blue Wallet, which is using some more generic terminology, more specific to the Hyperledger Aries protocols, which can be helpful for developers, but users may not fully understand what those terms mean. The Purple Wallet has been configured with a locale that the BC government has curated and prefers, which has more descriptive headers on the dashboard and uses more clear language on the actions in the left navigation. Very briefly, these are simply two JSON files with a primary locale as the one you prefer, and also a backup locale. So in this example, if the BC Gov does not want to override something in the EN locale, it simply does not define it, and it will fall back to the base locale. This is going to be a demonstration on how the business partner agent can establish secure connections with any Aries, Hyperledger Aries based wallet. We can go to secure connections. We'll see that there are none. I also have two instances of the business partner agent. So these are two wallets that are going to connect to each other. The first thing we can do is we can add it by DID. So looking up the public digital identifier for the wallet we would like to connect to. The way we're going to do that, you might get shared this through an email or a message of some kind. But if we get the DID of this teal wallet and it's shared to the owner of this purple wallet, the owner of the purple wallet can then input it into this form, and we can look up for that organization. And we can see that there was a result. This did resolve correctly. There's no public name, so we can identify it. We happen to know that this is the Blue Wallet. In this example, we will leave auto ping on, and there's nothing in that public profile, and we can add that partner. And we've now started the Aries protocol to initiate that connection. We sent a request, and we can actually see that in the Blue Wallet, there's now a notification that there is a connection request pending. Again, the name is anonymous. We don't know what the name of the exact wallet is, but this should be a business context that should allow you to identify this wallet properly. So we're going to edit this as well, and we're going to say that this is the Purple Wallet. You can save that. That's just a label for our local reference. That doesn't change anything on the ledger or anything that anybody can see publicly. And we can inspect the public profile, and let's accept this connection. It's now in the state completed. And if we return to the Purple Wallet, we see that there's an update, and that there's been an event where the Blue Wallet has accepted the connection request. And we now also have the completed state. And we can now resume with any other Aries presentation or credential exchange. This is going to be an example of how the business partner agent can create proof request templates so that proof requests can be reused across multiple connection or in multiple instances. We can see that in this example, the Purple Wallet is going to request a piece of data from a person. There's been no data exchange, but we'd like to verify that they are an employee at this company. We're going to request proof, and we're going to be prompted that there are no proof request templates configured yet. So we will need to do that. Prerequisites for this is that for any schemas you wish to request, you will have gotten the did and the transaction and be able to import that. So here we have the employee credential, and we're going to make a proof request template that leverages that schema. So we're going to create a proof request template. It's going to be employee check, and we're simply going to prove that they, and they'll only need to present their badge. So the data requested, we're going to request some data from the employee schema. In this example, we won't need to know their hire date, so let's not request that data. We actually don't need to know their ID either. Let's just verify that they have a role that is appropriate to, let's say, let them through the front door or issue them a new credential with some other authority. We're going to keep this as a very simple example. So we now have a new proof request template called the employee check. We're going to go to our secure connection, and we're going to request a proof. And now we have that template, and we're going to send that request. So the purple wallet now has an employee check. And here we're going to go to the holder. So in this wallet, we have an employee badge that was issued by the purple wallet, but we also have a connection to the front desk. The front desk has sent this request. I am the prover of this exchange, and data has been requested of me. So I'm going to inspect this this presentation exchange, and see that some data has been requested around this employee schema, which I happen to have a credential that matches that schema. They're only requesting the employee role, and the business partner agent is going to provide the user with a list of credentials that they could provide that would satisfy this proof request. In this example, we only have one credential, and it applies to this scenario. But if my wallet contained 100 credentials and only one of them was of this schema, only one credential would be shown here. And if there was no valid credential to respond with, that would also show. And we can show that example later. We're going to select this, and we can see that we're about to respond to this connection, and we're going to provide the value member. So I'm happy to reveal that information. I'm going to accept that presentation exchange. Presentation has been sent, and we can now see that through the secure connection, a notification has happened, and we actually have received the proof presentation was accepted, which means that the data was actually provided. And we can now see that there's been a response. The presentation is valid, means that it has not been tampered with in any way. The cryptography around that is based on the Hyperledger Indy and Hyperledger Aries protocols. And we can see that this employee credential had an employee role field, and the value that was responded, the value that the connection provided was member. We can see exactly who issued the schema, the credential definition it was issued with, business partner agent will show you the history of events. If, for example, this presentation request could sit for as long as the prover wanted to, so it might be responded to the next day, that would still be a valid execution of this protocol at the Aries level. And it would stay in that request sent state until it was responded to. We're going to close. You can see this has been verified. This exchange is completed, and the holder side also can see that the presentation that was sent back has been acknowledged, so this exchange is complete. This is going to be a technical demonstration on how the business partner agent can issue credentials through Aries secure connections. We have two business partner agents, each with a connection to the other. The issuer must also have configured a schema and a credential definition. So those are prerequisites before you would be able to issue any credential. If we inspect the connection to the blue wallet, we can see data that's been exchanged. So far, no data has been exchanged. Purple wallet is going to issue a credential to the blue wallet. We're going to select the credential definition based on the employee schema and the credential definition tag local. And we are now presented with the form to populate the fields that we'd like to include in the credential and issue. We can say the employee hire date was start January 1, 2021. The employee might need to present their ID, and they might need to present their role. In this case, they are simply a member of that organization. We can then submit this, and directly through the secure connection, peer-to-peer, the blue wallet now has a notification. There's no task because it is automatically brought into the wallet. So in this example, we've configured the wallet to automatically accept credential offers and automatically store them in the wallet. There will be a future demonstration on how the user may inspect that offer before receiving that credential and storing it. But in this example, the wallet now contains a verifiable credential of type employee. The blue wallet may relabel this my employee badge. With the contents, it is known that it is issued by the purple wallet and when it was issued. The purple wallet can see through the connection that the offer was sent. There has been the Aries protocol has been executed to completion, and the credential has not only has now been acknowledged by the partner, and this transaction is now complete. This is going to be a technical demonstration where the business partner agent can enable holders to accept or reject proof requests that have been made of their data. In this example, this wallet has a connection to another wallet that's been labeled person. We can request proof from them, and we're going to create a different proof request template. And we're going to request their entire employee badge. We're going to employee schema, and we're going to request all three fields. We're going to leave those all checked, and we're going to save that template. It is also sent that request off, and we can see that the full employee badge request has been sent to this connection. The holder of the wallet has received this request, and a proof has been requested of this wallet, and we're going to inspect this. And as the holder, I hold this credential. It's in this digital wallet, and I can see that what the data that's been requested of me is employee hire date, employee ID, and employee role. Now, the governance and business process that your example might have might require all three of these fields for the verifier to do the next step of the process. It might be something that is date dependent or role dependent or ID dependent. But in this example, let's say that it's just the front desk. You're trying to get in the door. You're trying to prove you are who you are. But you don't need to know the date that the employee was hired. And the holder can choose to decline this request because they don't feel comfortable sharing that information. So simply, we can just hit decline. This agent has kept a record that this request was received and that we have declined it. And what we can see in the verifiers state on the verifier side is that we sent this request off. We were the verifier, but it was declined. Currently, we don't provide any text to the user to maybe add more description on exactly why it was declined. So for now, we simply say that no reason was provided, but it was declined on purpose. It was not simply forgotten. And we can see that this is the request that we sent off, and there's no data to inspect or verify. This is a technical demonstration of the business partner agent can allow holders to review credentials before receiving them and storing them. In this example, Purple Wallet will look at the details of its connection with the Blue Wallet, and we will issue them a credential. We will issue them the employee credential and state that they were hired on January 21, 2202. This is a good example of a simple typo or data correction that might need to be made. We'll give them an employee ID and an employee role, this time of admin. We will submit that data. We can see that the offer has been sent. If we investigate the Blue Wallet, we will see that there is a pending credential offer that they can receive. We can look at the details of this credential content that's been sent to us, and the user has a chance to review it before this protocol is finished. In this example, the user would probably decline as there's an error in this data. So the user can decline this offer. We can see that the state is declined, and the issuer can see that there's been a problem report submitted that the holder has declined this credential offer. We can actually investigate the offer that we sent them, and maybe we can see that there was an error. So let's issue a correct credential. In the same manner, we're going to issue another credential. This time we are going to put in the correct date, January 2021, with the same employee ID and admin role. We can submit that, same offer sent, same notification, but in this example, the user would review this data and accept it as in their wallet. We now see there's a credential acknowledgement, and in our own wallet, we now have another employee badge. This one, including the admin on January 2021. And this is going to be a technical demonstration on how a web application can be protected with verifiable credentials. On the left, I've attempted to log in to a business partner agent, and it is protected by a key-click instance, which is using the OpenID Connect standard. Also configured is a verifiable credential verifier, which has been configured for a specific proof request. We're going to attempt to log in using that identity provider method. And we're going to see that on the right side, I have a wallet with no credentials in it. I'm going to attempt to scan this challenge. This is going to challenge me to present that I have the necessary credential to gain access to this web application. And my web app, my digital wallet on my phone is telling me that I have no credential that will satisfy this challenge. So we're going to cancel, and we're going to go obtain one. So in this example, we've configured this instance to also allow logging in with IDER, which we're going to do. After logging in with IDER, we're going to establish a secure connection to my mobile wallet by generating a QR code and having my eStatus wallet on my personal device scan this QR code. We can see that my personal wallet is now attempting to connect with this issuer that wants to issue me an access credential. That's the goal here, is to obtain an access credential. We're establishing this secure peer-to-peer connection. And we can see that both the web app has a new secure connection, the test VC login connection, and my mobile device also has a secure connection to the instance named Sandbox Governance. I'm then going to issue an access credential to the digital wallet. And we're going to receive that in my personal digital wallet. This exchange can be done through any other means, but once the connection has been established through QR code or any other authentication method that verifies that you are sending this connection to the appropriate person, everything else is done within the Aries protocols. So I now have a pop-up that says you have been offered a new credential. Let's view the credential. It simply says that you are a role member. I'm gonna accept that credential, and it's now held. We're gonna see that I now have this credential held in my wallet. And it has the value member as its business role, and it was issued by and at. So next, I'm going to log out of this system and I'm going to attempt to log back in using verifiable credentials. I'm now going to scan this same proof request challenge on this device, and I'm going to view this request, and it's going to inform me in my digital wallet. It's going to look through all the credentials I have and the request that's being made, and see that I do have an option to satisfy this request. I'm going to select this credential and present that to the identity provider, which will then pass that information along to the OpenID Connect platform, which is then going to issue a JWT token to my browser. And now that is used for the remainder of the session. So very quickly, there are again 3 components to this. In this example, we have the web application that has been protected by an OpenID Connect platform. And the OpenID Connect platform has been configured with an identity provider that leverages a service that knows how to verify verifiable credentials. In this example, BC Government, the Digital Trust team has constructed this service, which has been deployed by them, and uses configuration from this repo, which we have pull requested and deployed in that specific instance. This is going to be a technical demonstration on the business partner agents featured known as public profiles. Here we have a business partner agent. It has not been configured with any public profile. We are going to set up the profile. This page will show the profile once it's complete. It can also be accessible as a document, organizational profile document. We're simply going to label this as the blue wallet. We're going to see that this is set to public visibility. We're going to save. We'll see a few things like we use that as the name in the top left, as well as visible on this public profile page, as well as enabling the dashboard view to show instead of the set up your profile page that we saw earlier. On a different business partner agent, we're going to do the same thing. We're going to set up the profile, and we're simply going to label this as the purple wallet. So now that this organizational profile document exists, the business partner agent has been configured to do a few things. One, first, if we inspect the ledger, if we inspect the Indy ledger, we will see that the DID's written. So let's confirm that. Again, this is quite a technical feature as it only exists in the business partner agent and is not part of the Aries protocols. We have 9N1, and we will see here that there is a transaction with 9N1 that has not just published an endpoint to the ledger, but also a profile. And again, this is unique. If I make a GET request to this endpoint by simply dropping it in as the URL in my router, if I make a GET request to that endpoint, I get a document. I get a digital document. This does not hold all of the cryptographic necessities needed to verify information in this document, but it does show, like was configured, that the legal name was Blue Wallet, and we can see the other fields that we left empty as well. So what this is a endpoint that is written to the ledger as an attribute transaction type, and anybody with this DID that would know to look for it could look up that attribute on the ledger, see the profile attribute that's been written, see this profile attribute here, and would have to know that you can make a GET request to find information about that wallet that has been configured to be public. And this is utilized within the business partner agent in two ways. We can go to the existing connection and we will see this can be used in a few ways. Firstly, let's look at the way this happens if we look up a partner by DID to connect with them for the very first time. So in this example, Purple Wallet does not have any connections, and we're going to look up by DID. Let's take an inspection of the ledger, and we're going to look up this DID. We're going to put in the prefix, and we're going to search. And now, the first time we saw this, we saw that no data appeared, and now we're going to see that there's actually an organizational profile that has been set to public. So this is not information on the ledger. This is not information being transferred as a verifiable credential either. This is simply self-attested data, self-proclaimed data that the holder that you're about to connect to, the wallet that you're about to connect to, has published about themselves. And we can add this. We can do the same over here. Let's remove this existing connection. And in the vice versa, on the other side, the Blue Wallet can now see, hey, there's been a connection request sent, but also here's the organizational profile of the initiator, the person that wants to connect to you. Again, neither of these features will be populated unless the other side is a business partner agent, as only business partner agents know how to write and read and publish this data. But it's an interesting feature that we hope the Aries platform might consider adopting in the future. We can accept that. But not only can we include this one organizational profile document, we could also make other types of things public. For example, I could choose, if I wanted to make the public profile, the employee badge as a public document. And we can see that in the top right. And what would happen here is we can see that not only is the organizational profile document shared, but also an employee document is now shared. We also show that it's been verified. And we can see that. Again, if they choose to make this not public, and we refresh this profile, it will disappear. Proof requests and the verification of that data is not sufficient, does not execute the Aries protocols, but it does allow for a better distributed connection and gathering of the ecosystem without needing to make formal proof requests and make connections with everybody you're interested in. This is a demonstration on how the business partner agent can create an Indy schema and publish it to a sovereign-based ledger. First, you can go to Settings, Schemas, Credentials, Definitions, and Trusted Issuer Configuration. We will then create a schema. Schema label is its friendly name. We'll call it an employee credential. It will need a name to be written to the ledger, and it will be version 0.1. There will be some employee ID number, some employee role, and let's say there's some employee hire date. We can then submit this. And we can see the schema was successfully created. If I inspect the ledger, which I'm running locally on this machine, we will see that there's been a new schema published with the transaction type schema, name employee, with those three attributes. This is going to be a demonstration on how the business partner agent can create a credential definition on an Indy-based ledger. We've already created this schema in a previous example. If you need to see that, please refer to that instruction. We can then select this employee schema. We'll get its transaction ID. We'll see the attributes, and we can click on the sub-tab, Credential Definitions, and we can add a credential definition. Credential definitions are required if you want to issue any instance of this schema. Tag required. We can say that this is local tag. This would be useful to distinguish between multiple credential definitions. For example, if one was revocable and one was not revocable. This may take a minute or two, but this is, again, a required step if you want to issue any schema. You need to publish this credential definition on the ledger. We'll see that was created successfully. We can close this. We also see that the business partner agent has now marked that you can actually issue this employee credential. And if we go to the ledger, we can see that there's now also a credential definition with that local tag that I created with these attributes, again, the same attributes as the schema. This is going to be a technical demonstration of how the business partner agent enables users a interface to construct complex proof requests. In this specific example, we're going to look at establishing predicates and trusted issuers. Here we have a wallet. It has two credentials based on the same schema. One was issued by the Climate Action Secretariat. In this example, that says they are in good standing. And another credential issued by Energy Mines and Low Carbon Innovation, also saying they are in good standing. Copper Mountain Mine is the holder of these. Again, you can see the issuer and good standing, yes. The issuer, good standing, yes. So the verifier doesn't just need to see a credential that says they're in good standing. We're also going to need to be very specific on the issuer of that credential. So in this example, we've imported that compliance schema. We have added 2 trusted issuers based on their DIDs, and we've labeled them locally within this instance. PwC, who is acting as kind of an auditor in this example, is going to make a proof request that they are in good standing. In this example, we're going to need to create a new proof request template, or proof template. Specifically, we're going to ask if they are in good standing with EMILI, the Energy, Mines, and Low Carbon Innovation Ministry of BC. So in this example, we've loaded it up and we can see that those trusted issuers are automatically populated. But to be very specific, I'm actually not going to accept one that comes from CAS. So we're going to ask for the field is in good standing, and we're only going to accept it if it was issued by EMILI, and we will not accept it if it was issued by anybody else. In the presentation exchange, this is a restriction on this requested attribute. Something else that we're going to demonstrate as well is we can also establish operators and comparisons on these values. So in this example, we're going to be very specific that is good standing must exactly equal yes. We're going to create. This is immediately going to send a request to Copper Mountain Mine. We're now going to use that proof template to make a proof request based on those specific details we established earlier. Copper Mountain Mine connection, we're then going to request proof, and we're going to simply reuse that specification we designed. We can send this request. The request has been sent, and we can see that Copper Mountain Mine now has a notification that they've been asked to present proof that they are in good standing. We can see a little bit of the details, that the is good standing value is going to have to equal yes, and that the issuer specifically came from this. So if we only looked at the schema, we would have 2 credentials that satisfy it. However, because the requester, the verifier, has put this restriction on it, only one of our credentials is valid. So we can select this credential. That restriction has been met, so we are going to respond with is good standing. And proof has been sent. Again, this is very important for most business scenarios, because not only do you need that the credential exists and has the right values, you also need to ensure that it was issued by the appropriate party. You're not going to accept a driver's license that was issued by Fred's driving school. You're going to look for the one that was specifically issued by the government of BC.
In this demonstration, we'll be illustrating the basic messaging capabilities of the BPAs and the Aries protocol. Now, this is secure messaging only between these 2 partners. Setting up the screens, on the left we have the blue wallet, and on the right we have the purple wallet, and we've already established the secure connections. Since these both support the Aries protocols, we will see them in the chat window. And for now, we will send a message from the blue wallet to the purple wallet. Basic messaging is secure encrypted messaging between 2 partners only. It should be used to help clarify the issuance of credentials and other out-of-band business matters. We can see in the bottom right on the purple screen, we've got an indicator saying we've got a new message and an indicator saying which partner had sent it. So we click on that and we can see the message. And now we can reply. Now we can see in the bottom middle of our screen that there's an indicator on the blue wallets that they have a message.